Hello and welcome to case number 3, household spending. The goal of this case study was to model and predict household spending. Data was provided not only from in-house sources but also external sources purchased to enhance the dataset. The data provided had a wealth of potential information. When combined, it was over 80 columns. When added fee treatment was added, it was well over 100. The data included magazine subscriptions, loyalty program info, donation information, consumer data, and even political information. In order to capture as much information as was provided, all the different data sources were merged into one data set, and then various treatments were done to the data to make it usable. The initial analysis of the data showed that the best indicator value for prediction was the Mosaic Z4 column. This column represented the Experian Mosaic system for geodemographic classification of households. Mosaic is an extensive classification system using over 300 data points, and the thinking and/or hope was that if the model could predict that household's classification level, then the marketing team could actually tap into the information provided by Mosaic for each of those classification levels. And then they could extrapolate from all that, combining that with their existing data, an enormous amount of extremely targeted information that would be able to help them predict spending habits and also send out targeted marketing campaigns well beyond anything that they currently can do. If you look at this example, this is from the Mosaic site. You can see here that they have a multi-tiered classification system where they group, the top 6 or 4, or, the classification is determined by them, how many are in each main category, such as the power elite, flourishing families, booming with confidence, etc. But then you can also see within that they have subdivided that amongst other subcategories, which are more specific. So jet set urbanites versus couples with clout, one of the things would be the determination of where their residence is, how much their home value is in relation to their zip code and in relation to nationwide, their income level, their education level, children versus non, etc., etc. It's an extremely extensive classification system. And then as you can see here, this is the analogy that came to me when I was looking at this was similar to the agile project management methodology of user personas, where a Bohemian Groove is a user persona of a very specific type of individual and all of the traits that go into making up that Bohemian Groove persona. You can see here there's an age, there's type of property, household, where they live, home ownership. You can also see here how they compare nationwide in terms of education, home values. It's an extraordinarily extensive amount of information and it is very akin to the idea of a user persona in that it is describing a specific targeted person that you want to interact with, or in this case, that the data we were hoping the data would provide that would allow for targeting Bohemian Groove versus, going back one page here, the American Royalty tier. And what the difference is between them might be determined where they live. It might be income level or education, but you could in fact then make more accurate targeted marketing campaigns based on these indicators. The data sets were per environment. There were 3, training, testing, and prospect, were divided into training and testing sets, and the ratio was changed between each environment. For training, we wanted a majority of the data, 80%, to go towards the training, whereas for the prospect environment, I only allocated 10%. The idea was that once the model worked and had been gone through multiple times between training and testing sets and then finally getting to the prospect, less of the training would be needed for the final modeling round. The model was developed using 2 different methods. The model was developed partially from the results of the LEAPS package, which allows for iteratively determining the best subset of predictors to use. Because this Mosaic Z4 column predictors that could affect the classification, I needed to use something beyond um, anything that I had previously used to try to get the best subset of columns. And the result of running that process was a formula, was then translated into a formula, and that formula was actually fed into the subsequent training and modeling process, with the goal being to get the best fit. The LEAPS package determined that there were 8 main predictors, and then that was translated into a formula, and again then passed into the model and training, which used a random forest. Because of the complexity of the data, the training was much more involved than normal. After having determined the best subset of predictors, the model then used random forest regressions to train the models using the LEAPS formula as the input. The other thing that was done was to achieve this, both the training and the models were run using parallel processing in R, which meant instead of 100 runs to train with, it was actually 900 because there were 9 cores that were then applied to run 100 times. And this pattern was repeated throughout the training and modeling. Running the LEAPS to determine the best subset of predictors was extremely resource intensive. Even with 9 cores available, the function for determining the best subset took more than a half hour to run, because what it does is it runs essentially a for each loop where it starts with 1 predictor and then 2 and then 3, and it builds up and goes through actually all of them. If you want all of them, I actually limit it to only 1/3 of them as the max. Once it runs, then you can actually take that data and determine which run was the best, was the best subset, and then that output was saved and the code was removed so that the process did not have to be repeated each run. In other words, I hard-coded the resulting formula of the output for the LEAPS function because I didn't want to have to spend a half hour every time I went through step through the code. Unfortunately, the models were not able to predict the Mosaic tier, no matter how many times the model was run. The best accuracy level achieved was approximately 3%. Even with the additional runs of the training and modeling, which were hoped would weed out any overfitting, in this case, I don't think it mattered. The model was nowhere near as accurate as I would hoped. There are 2 main reasons for this, one of which I did not know when I chose that column as the target variable. The Mosaic classification system does rely very heavily on geospatial information. Home values compared to average of zip code, whether you live in a rural versus suburb versus city, all of that data contributes to the very specific classifications that the model gives. And since most of that data was essentially fudged or had been altered previously, coupled with the only real way to have leveraged it would have been to have a function that, for example, went out, took the zip code that was listed, and then went out and got the information that was missing as part of the overall program. The model wasn't able to predict as much as I had hoped. The data also had a lot of other data fields that had been manipulated before, so that also meant that even indicators that might have been helpful as predictors weren't, because the information actually may not have been valid in them. Objectively, having learned about the Mosaic system, I do find it hard to understand why any organization would not try to model their internal data collection to roughly match the data in Mosaic, the data points in Mosaic. This classification system is so extensive and so specific in the personas that get developed. I don't really understand why any organization would not be trying to copy it, or at least roughly hook into it in some way to be able to leverage it. Doing so would give any organization an ability to target communications beyond anything previously available to them. Thank you very much for your time, and thank you for the semester. Bye.